Today we're going to be talking about what is a function, what is not a function. So we want to think about what is a working definition of a functional relationship. Okay? So think about that, and we will write down what you guys discussed. Just write down each x value. And your x value, we put in parentheses, represents what's called, it's like the input, what you plug into an equation. Okay? Each x value can only have one y value, which is the output associated with it. All right, I'm not going to write associated with it. Right? Basically, that's a condensed version. Each x value, which is the input, can only have one y value, which is the output. All right. So, for example, if we had a table right here, we had an x, and we had a y table. Okay. If I plug in, let's just look at this one right here. This point right here, let's just estimate. If I plug in, what would you guys estimate? If this is a 2 right there, that's about a what? 1 point, we'll say 1.8, 1.7. About what height do you think this would be at? That's 4.6. So maybe about a 5? Okay, maybe a 5? Okay, so at 1.8, we're at a 5. Do you see more than one y value for that x value? Is that there's only one y value for that particular x value? Only one. Now, there's a test that we use called the vertical line test. And the vertical line test deals specifically with a vertical line. Vertical line, in and of itself, is not a function. Okay? If I were to draw a vertical line up here, I can draw a vertical line at any place on this graph right here, and it's only going to touch that graph how many times? It's only going to touch it once. No matter where I draw it, it's only going to touch it one place. So that lets you know that this is a function. Now, this vertical line is not a function. This vertical line is right here is at x equals the value of 8. This vertical line is at x equals the value of 4. Why is a vertical line not a function? Let me show you why. What point am I at? What ordered pair am I at right here if I were to make a little table? Yeah, that's at a 4 and an 8. What value am I at right there? 4 and a -4. See how these right here? These are the what? They're the same. But these are different. So if you plug in a number that's the same number for the x, but you have different y values, that lets you know that that's not a function.
So for it to be a function,
X can't repeat. Okay? All right, so that's another way of thinking about it. Whatever you plug in, you should get one output, not two different outputs. So let's look at this word problem. We're going to zoom out and take a look at the word problem. It says, the input value x is what for problem number 5? What's the input? A car's license plate. So I'm just going to put x represents the license plate. And what does y represent in this problem? Haley, you read it. What's y? What's the output? Yeah, the make and the model. The make, but plus the model. All right, so we got to ask ourselves, is this a functional relationship? So let's say Dylan's driving through a school zone at 50 miles an hour, all right? The cop sees him, he's on his phone, he pulls him over. What's the first thing the cop's going to do when he stops Dylan in the school zone? What's he going to do? He's going to check his license plate, right? He's going to type in the license plate, all right? When he types in the license plate, how many cars are going to be associated with that particular license plate? One make and model, right? So that input that he types in gets how many outputs? One output, which is different. So this license plate gives one make and model. So that lets us know, is this functional or not functional? What would you say? Functional. This is a function. Now, how could this not be a function if they rearranged the words and said X was the car's make and model and Y was a license plate? Because what's your make and model of your car? Is that, do you think there's going to be only one 2014 Ford Mustang? No. You could say, all right, we're going to plug in 2014. That's the make, right? That's the year. The model's a Ford Mustang. And guess what you're going to get? You're going to get a whole bunch of different license plates numbers, right? That all represent what? The 2014 Ford Mustang. So that wouldn't be a functional relationship. That would be a relationship. It would be a relation. It just wouldn't be a function. Because each input has to have how many outputs? One. That make sense? All right. We're going to do the vertical line test on problem number 7. Right here, I could draw a vertical line right here. I could draw a vertical line right here, or right here. I could draw it a lot of places. How many places does it touch? 2. If a vertical line touches a graph more than one place, that lets you know that what? It's just a relation. It's not a function. It's just a relation. So this right here would be considered not a function according to the vertical line test. So on your assignment, to let me know that you're actually thinking, draw in some vertical lines and show that you know that it's either crossing once or more than once. Okay? So anything more than once is not a function. Now in problem 8 and 9, it's asking you, is this a function or is this not a function? All right, it's a pretty simple one. All we would have to do to solve this is do what to both sides? Just simply add an x over here, add an x over here. So, how many x's do we have right now? 4 x's, that's right. We have 4 x's. So what I'd like you to do is you have to ask yourself, y equals 4x. Is this going to be a functional relationship or not? We'll go to your graphing calculator. Hit y equals. Type in a 4 and an x and hit graph. All right, so right now, everybody find your graphing calculator. All right, they're getting graphing calculator right now, and I can't find a way to pause this. Come on, I want to pause this. Okay. Click go. All right, so now we're recording again. So we can see from our graph that this is what type of function is that? Linear function, that's right, because it forms a line. Very good. All right. So now what we're going to do is we're going to go to our next. Let's see here. Down. Let's go over to the next problem. That one looks a little intimidating right there. All right. We have x equals 5 parentheses y minus 1 squared. All right. Now, in order for us to use the graphing calculator, we need to change it to what form? We need to change it to y equals. So we got to figure out how to solve for y. Now, right here, you see how this is being squared? Okay. What's right next to it? We have a 5. So no, we can't distribute first. That would be bad because we have to use PIMDOS. We would have to square this, then multiply it by 5, but we're not going to do that. We want to solve for y, which means we got to get rid of this 5 that's being multiplied to this parentheses. Okay. No, what's the reverse operation of the multiplication? Division. That's right. So we would have to divide both sides by 5. So this 5 cancels out this 5 to a 1. And here's what we have left. We have an x divided by 5 equals parentheses y minus 1 close parentheses squared. Now I'm going to rewrite this to make it a little bit easier. Here we go. want you to notice I've not changed anything. All I did was just move this here, move this here. They're both equal to each other. All right? Remember, this is just basically saying A equals B, then B will equal A. Haven't changed any of the properties. All right? Now, if I gave you this problem, if I said x squared equals 49, what would you say x is equal to? But technically, if I take the square root of this and take the square root of this, technically you could say x is equal to a plus or a minus 7, because negative 7 times negative 7 is also equal to the number of 49. So what operation do I have to do to get rid of the square? That's where what function? The square root function takes place. So we have to take the square root of this side, and we have to take the square root of this side. Okay. What's the square root of y minus 1? Equals. Well, what did I do up here? I said it was a what? A plus or a minus. So I have to say plus or minus square root of x divided by 5. Very important. You do plus or minus. Right? And last but not least, simply do what? Add 1 to this side, add 1 to this side, and your final equation is y equals plus or minus square root of a number divided by 5 plus 1. So what I'd like us to do, I'd like us to look at what this will look like in the graphing calculator. All right, here's the steps, everybody. What I want you to do, I want you to go to y equals. I want you to clear this out. I want you to hit second x squared, and then hit alpha y equals and enter to get that fraction mark. Alpha y equals enter. That'll give you the fraction mark inside of the square root. Type it in x, go down, type in 5. Very important. You hit this right arrow twice to get out of the radical. You'll notice that that radical finally gets closed up. And then you put plus a 1. All right, let's graph this. This is a square root function. Right here, this is a function. You guys see? Would this pass a vertical line test right here? By itself, in and of itself, yes, it would. Okay. What did I say our answer was? Was it just plus, or was it plus or minus? So here's what you need to do. Go to y equals, go down to the red one, right here, y2. Start with a negative sign. Start with a negative. Then hit second, x squared, alpha, y equals, enter. Type in the same x, divided by 5. Make sure you go the right arrow twice to close it off. Put a plus 1. Then hit graph. Now what do you notice? What was a function, if I were to do a vertical line test, how many places does the vertical line now touch? 2, right? No matter where I put it, except for right there. Right? But if you can do 2, so remember, the blue part of the graph was y equals the square root of x divided by 5 plus 1. The red portion was y equals negative radical x. Okay? So you have to graph both of them. So listen. Here is a shortcut. If you can remember this shortcut, this will save you a lot of energy. Just remember this. Ready? If you have a y equals an x squared, that will always be a function. Anything y equals x squared will be a function. Because that's either going to open up or it's going to open down. But if you have x equals y squared. This will not be a function, not a function. It will only be a relation. It will either open up this way, or it will open up this way. So that's kind of the shortcut. That's when I look at the problem, automatically I know, oh, that's not going to be a function. What I wanted to show you is how to solve for it first, and then what would it look like if we actually graphed it. Okay, so you can see that it wasn't going to be a function.
It's like,
Well, if you go to a bakery, you can find some pound cake and you can enjoy it, which I think you probably already have at some point in your life. All right. So right now, everybody, number 10. What I would like you guys to do for number 10 in your journal, title this right above it. Right. Function notation. I'm sure you can find something. Function notation. Oh, I know. It's really frustrating.
I hate when you tell us to write stuff over it because I've already written other stuff and then you're like, I can't write it over it.
Sorry, I know, I'm a horrible person. So, here's what I would like you to do. We are going to evaluate in your journal each one of these, okay? So we're going to start with h of negative 1. What I need you guys to understand in function notation is whatever number that you see right here, you need to plug in wherever you see an x. So we're going to start with letter A. Go down here, and it's h of x equals x squared minus 8x plus 1. All right? So if I say, what is h of negative 1, what number must I plug in for the value of x?
Negative 1.
That's right. So let's plug it in. Negative 1. So go ahead, Raymond. Solve it for me here. Evaluate it.
E negative 1 squared is going to be 1.
Good.
Then times and negatives and get 5.
Yeah, very good. Just bring down the one right there. So what does that all add up to? Boom. So right here, when you plugged in a negative 1 into this function right here, when you plugged in a negative 1, it evaluated to the number 10. Okay? That's what it's asking you to do. Now, we're going to go ahead and do the next one. Next one says, not h of negative 1, it says, what's h of 2x? So now, what am I going to have to replace wherever you see an x? What do I have to plug in its place? 2x. So I got to plug in a 2x here. And I got to plug in a 2x here. All right, I'm going to pick on you, Emily. What'd you get right here? Wait for it. Squared. There we go. All right. What do we get right here? 8 times 2x. Boom. And that's your final answer right there. Now, if students right here, either, by the way, my other period, they forgot to square the 2. They got the x squared, but they forgot the 2. Okay? So remember, you have to multiply. 2x squared means 2x times 2x, which gives you 4x squared. All right, last one. Here we go.
No, you need to write in the journal.
Yes. So on your paper, on your assignment, put work done in journal and just transfer over the answers. So what would that look like? Transfer over the answers. Here's what it would look like, right? So A, you have 10. This one you have 4x squared minus 16x plus 1. And you do that. But as far as your work, where's your work done? Your work is where? Yeah. Let's put in journal. What I don't want to see is I don't want to see the words in journal and blankness on the page. Okay? So make sure I know that, hey, you're transferring over the answer that you did the work in. Okay? All right. Last but not least, we have to take x squared minus 8 times x plus 8 plus 1. This is the most difficult one. I can see Bailey rolling her eyes in the back of her head going, oh my gosh. All right, so x plus 8 squared means you have to do what? X plus 8 times x plus 8. Now, normally you probably do the boil method. We're going to show you a little shortcut. All right, here's a formula you want to put in your journals for you to remember. I want you guys to put x plus a, and I want you to square that, okay? If you have a coefficient of the number 1 in front of the x, so if it's just 1x, this is a shortcut that you can do. It will always be x squared. The second one will always be twice whatever the a value is, double that. And the last number will always be whatever a value is squared, every single time. So, right here, what's that times 2, or that plus itself? 16. So this is going to be, you're going to start with x squared, then you're going to have 16x. And what is that number squared, or multiplied to itself? So the fast way, when I see that automatically, I just quickly write x squared plus 16x plus 64, because I know 8 plus 8 is 16, and 8 times 8 is 64. Okay? So this right here could be a shortcut that would allow you to get things done a lot faster if you remember how to do it over and over again. Now here we have to distribute negative 8 to both numbers. So we're left with negative 8x and a negative 64, and then we have 1 at the end. So I did negative 8 times x, negative 8 times 8, and brought the 1 down. Now, there's a whole bunch of work up here, so I'm going to highlight things that are like terms. Here's a 16x. Here's a negative 8x. Here's a 64. Here's a negative 64. And there's a 1. So right now, what are we looking to combine? We're looking to combine like terms. You see why I highlighted them now. Hopefully, it can help organize it. So, we have an x squared. How many x's do we have remaining? 8 x's. A 64 and a negative 64, those cancel each other out. Those are called additive inverses of each other. And then all we have is a 1 at the end.